right, hey guys, we're going to be talking about balancing chemical equations. All right, so first off, copy these equations and then see if you can figure out if they're balanced or not balanced. So just look at each of them, and then we'll come back at the end of the lesson. I'll let you know which ones are balanced and which ones aren't. All right, so copy these down. All right, let's go ahead and let's get started with our notes. So first off, copy this in your notebook. So a chemical equation is a way of writing out what's happening during the chemical reaction. So you've seen experiments, you've seen things happen, you've observed them, but now we're actually taking the elements in the atoms and we're figuring out what's happening and writing an actual equation on paper that represents it. All right, so this you don't have to copy down yet because we'll go over this plenty. But basically, your chemical equation is this whole thing right here. And of that chemical equation, you have your left side that is basically what you put into the reaction. Your arrow right here, that is yields. That means that the reaction is happening. And then you have your right side, which is what you end up after with. So one group like what I highlighted here, that's called a chemical formula, but the whole thing with the yield sign is a chemical equation. All right, copy this in your notebook. This is super important. This is the law of conservation of matter. It basically states that matter cannot be created or destroyed. It can only be changed. So basically, whatever you start with is what you end up with, but they may rearrange it to make it look a little different. But you can never lose mass or lose atoms. You also cannot create mass out of thin air or create atoms out of thin air. So you have to, whatever you start with is what you're going to end up with. That's the law of conservation of mass, or law of conservation of matter, same thing. All right, so here's an example. We're going to have a test tube with lead nitrate, which is green, and is placed in a flask that has potassium iodide. So this is what you're starting with. So these are the reactants. And here's an important part, is a closed system. So notice this stopper right here. This stopper is closing up your the system. So that way when the reaction occurs, nothing can escape. So this is a closed system, is an environment where matter cannot enter or escape. So let's say we take this and it's a closed system because there's a cap or a stopper in it. And note down here what the mass is. It's 238 grams. So then we're going to go ahead, we're going to create the reaction, and you're actually going to get lead nitrate can mix with potassium iodide, and they make lead iodine and potassium nitrate. So now you've got something different, you've got new chemical properties and all of that. However, look at the mass. The mass is still the same. So this represents the conservation of matter or conservation of mass. So what you start with is what you're going to end with. And notice again, that stopper makes it a closed system. So if you have a closed system, nothing can escape or enter. Now, if you would have had an open system, the thing that could potentially escape is gas. So you don't want any gas to escape. All of this in here could potentially be gas. You just don't see it, but it is trapped because it is a closed system. So if there's ever a difference in conservation of matter from your product, your reactants and your products, chances are what escaped was gas. So make sure you understand that. All right, and then here, what you're going to copy down is this part. And basically what we're talking about for chemical equations is however many atoms you start with should be the same number of atoms you end with. So if you look on the left side, oops, right here, if you notice we have 1 carbon, we've got 4 hydrogen because of the subscript, and we have 2 groups of O2, so that means 4 oxygen there. And then if you come over to the right side, which is what you end up with, so that's your products, you also have 1 carbon, you have 2 groups of 2 hydrogen, so that means 4, and then you've got 2 here and you've got 2 here, so that's also 4. So this is balanced. And if it's balanced, that means that it follows the law of conservation of mass or matter. All right, so now let's look here. We've got our reactants, which are on, I'm going to make this color like an orange. So your reactants are here, and then that's what you start with. Your products are here, and that's the result. And then the yellow means the reaction is happening, that's the yields. So reactants are on the left side, products are on the right, and then your yields is kind of like the equal sign, if you will, but it means that it's converting to, or it's producing that. All right, so in this chemical equation, which is the reactants, it would be this side. I like to think of products like product for math equation. So when you have a product in math, it's the answer for multiplication. So I kind of think of the product in a chemical equation as what's the result. So the yellow are the reactants, and if it would have asked for products, this would have been the products or product. All right, this one you can put into your own words. You don't have to copy all of this word for word, but basically you need to know chemical formulas. And for the chemical formula, you obviously have the element symbol. That's the H or hydrogen in this one. And then you have the subscript. So remember, the subscript always comes after, and that tells you how many atoms are in there. So that's, in this case, you have 2 hydrogen atoms that are bonded. You also have the coefficient, which is out front, and this tells you how many molecules or how many groups of that you have. So you have 2 groups of H2. So again, put this into your own words. You don't have to copy it word for word. All right, this you don't have to copy down, but you can if you like. But basically, the difference between coefficients and subscripts, if it's a coefficient out front, all that means is these 2 are not bonded. They're separate hydrogen. So you just have 2 groups of hydrogen. They're not bonded together. However, if you have a subscript, that means that these are actually bonded together. So it's 2 hydrogen atoms that are bonded together to form a hydrogen molecule. Same thing here. Here we have 3 groups. 1, 2, 3. 3 groups of Na2, so the subscript's 2, so that means that these are bonded. All right, same thing with water. You have 2 groups of water, and you have sulfur that has 3 oxygens, so just this is a 1 molecule. All right, so it says in this formula, what is the coefficient of chlorine? Well, coefficient of chlorine, look at chlorine, and it would be 3. All right, so this is important. Write this down. When you're balancing equations, you can only change the coefficients. You cannot change the subscript. And I said before, but if you were to have H2O, which is water, which is good for us, yes, we can drink that, we need water, all that good stuff. If I needed to balance this and I just wanted to make it H2O2, that's not good, because if you were to drink H2O2, that's hydrogen peroxide. And depending on the concentration, if you drink enough, that could harm you, potentially fatal. So when you change the subscripts, you're actually making a brand new compound, so you can't do that. You can only change the coefficients. All right, so now we're going to look at the steps here. Okay, so it says what you're going to do is copy this in your notebook. So what I would actually do is I would kind of split your page in half. I would write the steps on one side, and then I would write the actual equation with the process on the other. So I would kind of draw a line down the middle of your page, so that way you can get the steps and show all the equation and everything on there. So first you're going to write this equation in your notebook, and then we're going to make a list for each side. All right, so I've got hydrogen, and I've got an oxygen, and I just list those. And then on your product side, I've got a hydrogen and I've got an oxygen, so I've just listed those. So we're not counting anything yet, you're just listing your elements. Okay, next up, and notice it's the same equation. Next up, what you're going to do is you're going to count how many you have. Well, hydrogen, I've got 2. Oxygen, I have 2. And then over here, hydrogen, I have 2, but oxygen, remember, I only have 1 because there's no subscript. So after we've listed each of the elements, now you're counting how many are there. All right, next up, we're going to check to see if it's balanced. Well, we already said hydrogen had 2, oxygen had 2. We said hydrogen had 2 and oxygen had 1. So right now, oxygen is not balanced. So if it's not balanced, we're going to have to balance it by adding coefficients. All right, so step 4 is add or change a coefficient to try balancing the equation. Once you change a coefficient, cross out the previous numbers, and we'll kind of adjust as we go. So we said originally, hydrogen was 2, oxygen was 2, hydrogen was 2, oxygen was 1. So usually what I do is I start with the side that has the least amount, and then I make the coefficient so I can get to the other one. So I need 2 oxygens. So if I put a coefficient of 2 here, now I'm going to have 2 oxygens. However, that now changed how many hydrogens I have, because now I have 2 groups of water instead of just 1. So now I actually have 4 atoms or 4 hydrogens in there. So now I'm going to have to come over to this side to make this equal to 4. So the coefficient I'm going to have to add to H2 is 2. And once I do that, then I've got 4. Now they're both the same on both sides. So voila, it is balanced. And I kind of skipped a step there. But once you've got this all done, everything is balanced. All right, so now I already gave you the answer on the bottom here so you can check it, but let's just look. So remember, list on each side, and then you're going to count how many you have of each one. So I have 1 carbon, I have 4 hydrogen, and I have 2 oxygen. On this side, I have 2 oxygen here, but I have 1 oxygen here. So I actually have 3 oxygen. I have 2 hydrogen and 1 carbon. So this currently is not balanced. So now we need to figure out what we need to do to get it balanced. So I'm going to look at the side that has the least amount for hydrogen. So I'm going to look over here. I need to get this to 4. So if I put a coefficient of 2 here, because 2 times 2 is 4, then now I'm going to have 4 hydrogen. But that also changed the oxygen. So now I no longer have 3. I've got 2 oxygen here, and I have 2 oxygen here. So now I have 4 oxygen. All right, I'm not balanced yet because now I have to come over to my left side and I currently have 2 and I need to make it to 4. So if I put a coefficient there, that makes it 4. And now we're the same on both sides, and voila, we're good. All right, so now what we're going to do is we're going to figure out, are these balanced? If they are, great. If they're not, we have to balance them. So remember, list, and then count. I've got 4 sodium and 2 oxygen. I've got 2 sodium and 1 oxygen. So this is not balanced, so we have to balance it. So I go to the side that typically does not have as many, and to get sodium 2 to 4, we have to have a coefficient of 2. And once I've done that, now I have 4 sodium and I have 2 oxygen. So now I'm balanced. So this, that is balanced. All right, let's look at the next one. All right, NH, let's count. I've got 2 here, and remember 3 groups of 2 means 6. And then I've got, got 2 here, and then 2 groups of 3 also equals 6. So is that balanced? Yes, it is. And then here, let's list Fe, which is iron, HO, Fe, HO. I try to keep them lined up the same, even if they're not necessarily in the same order in the equation. So iron on this side I have 1, hydrogen I have 2, oxygen I have 1. This side for iron I have 3, oxygen has 4, and hydrogen has 2. That's definitely not balanced. So let's look here. First off, let's start with iron. So iron has 1, but we need to get it to 3. Well, since iron's all by itself, I can add a coefficient of 3, and I'm good there. But now, look at oxygen. On the product side, we have 4 oxygens, so I need to get this up to 4. Well, great. Now I have 4, but now I also have 8 hydrogens. So now I got to come over here and make that 2 turn into an 8. So if I already have, it's 2 for hydrogen, I have to make 4 groups of that. And then once I do that, then I have that. And then that is balanced. So you kind of do a little bit on one side, then you do a little bit on the other side until it all balances out. Okay, let's look at number 4. And then let's see if they're balanced. 2 and 2. And then remember, it's 2 groups of each one. All right, so we're balanced. So that's good. All right. And then what I want you to do is I want you to copy this in your notebook. So definitely label the parts and make it colorful just so that way you have it in one spot what all the pieces are. If you get stuck with balancing equations, I have a video on my slides that you're welcome to watch. That's down here. You are welcome to watch that if you need to. And then we'll be doing some assignments that goes along with balancing equations here. So remember, law of conservation of mass or law of conservation of matter says matter cannot be created or destroyed. It can only be changed. And then to balance, you have to count your reactant side, count your product side. And if they are equal, then that means law of conservation of matter was followed. And then also remember, if it's a closed system, it should be balanced. If it's not balanced, then you know that the difference would be gas escaped if it were an open system. So closed, it should be balanced, and open, if it's not balanced, that means that gas escaped. So make sure you take all of those parts, and then that is how you balance chemical equations, and that's the law of conservation of mass.